today. So, once again, 70x squared plus 90x. This comes from our last lesson, which was the GCF, correct? Remember the GCF is what, miss? Is it Arnoldson? Armstrong. Okay. Yes, you should be should have already passed it. Hurry quickly.
I'm judging right now.
Don't judge. Well, I don't like all the icing. That's why usually I go up to 8. Okay, here we go. So this is from 3.2, which is the GCF, which is another word for greatest common, well, not a word, an acronym for greatest common factor. Okay, you guys need to go with me recording. You guys need your little quieter so the main voice is my voice. Okay, when we do have questions, that's okay. My voice needs to be the main voice, right? Okay, so once again, what do? We do the factor, the tree of 70, the factor tree of 70. What is the tree of 70? Go ahead. 170, awesome. What's next? We always go with the next number, right? Does 3 go into 70? 4, 5, 5 and 14. And 6 go. Well, 3 can't go, 6 can't go. 7, 8, 9, and 10's on the other side to show us that we're done. Is everybody okay there? Okay, 90. What's in 90? 190. 245. That's horrible. Okay, onward. 4. See how if I double the 2, I can't cut him in half, can I? So 4 can't go. 5. And 18, good. 6. If 2 and 3 can go, 6 can go, and that is, I think, 15. 7. 8 can't go because 4 is not up there. And 9. 9 and 10, it wraps around, shows me we're done. Okay, so let's go fly a kite with Alex. Alex, what is the largest number they have in common? 10. Right? That's what they have in common. Okay, so with that being said, I can pull that 10 out. And do they have any x's in common? How many x's do they have in common? 1x. So I pull out the 1x. So if I pulled out a 10x from 70x squared, 10 times what gets me to 70? Equals 7. Does everyone understand that? Okay. I pulled out one of the x's, and there was how many up there? 2. So I need how many there still? I need 1 more. Okay. Because notice x times x here is supposed to be the x squared. Notice if I pulled out a 10 from 90x, if I pull a 10x from 90x, what's left over? Just a regular 9. No x's because I pulled that 1x out, didn't I? Everybody there with me? That's number 1. Okay, number 2. Fairly simple. Can anybody tell me without having to do the factor tree? Okay, what did we get with? What numbers do they have in common? What numbers do they have? They have a 10, and as Michael already said, in the p-value, they have a p to the 4th, right? Okay, they have a 10 p to the 4th. So if I pull a 10 from 20, what's left over? 2. Why is it not 10? Because I'm not adding, subtracting out, I'm dividing out, right? So 20 divided by 10 is 2. If I pull out p to the 4th and there's p to the 4th there, do I have anything left in there? Minus, if I pull out the 10, is there a number in there? Sure, what number is that? 1. Do I have to write the 1? No, but I am just for getting the practice. Does that make sense what I'm saying? Okay, and if I pull out 4 p's out of p to the 5th, or p to the 4th and p to the 5th, I'm left with 1 p, just 1 p, or you can just have p minus p. Any questions upon that one? Well, the other way, so once again, we're always trying to pull out the greatest common factor, right? Does 10 and 20 have other numbers that they have in common?
Oh, yeah.
What do they have? 2p4, 2p to the fourth minus c to the fifth. They did not pull out how much p was. So I will give them a half because they pulled out half of it. Michael. Okay, so they figured out it, so that's only half the work. We'll give a half. Alright. Okay, so once again, guys, we are pulling out the greatest common factor. Hi. Okay. Does every term have something in common? Yes. What do they have in common, Bill? They do have, who said it over here? A 6, right? They have a 6 in common. Do they have A's in common? No, these guys have A's, but this guy doesn't. So we can only pull out the 6. So if I pull 6 from 6, I'm still left with the 1 or the A cubed. Because I didn't just pull out any of the A's, right? Okay? If I pull 6 from negative 24, what's left over there? Negative 4A. And if I pull out negative 6 out of negative 24, that's going to be negative 6. Excuse me, negative 4. Okay? Great. Onward. Number 4. Number 4. 30x cubed y plus 25xy squared plus 10xy squared. Alright. So, Miss Hates. Are you okay? Can you tell me, if you need to do the factor trees, we can do them. Do you know what 30, 25, and 10 all have in common? They all have a 5. That's the highest, right? So if I pull out the 5, okay, what else do they have in common? Do they have anything else besides the 5? How about the x's and the y? Do they all have x's? How many? They only have 1, don't they? Okay. How many y's do they have in common? Do they have any y's in common? How many? They each have 1 again, right? Okay, good. So that's what we're factoring out. So if I pull a 5 out of 30, what's left over? A 6, good, Addie. And if I pull an x out of x cubed, how many x's are left? X squared, right? So I just said 2. If I pull y from y, is there anything there? There isn't anything. Okay, if I pull a 5 out of 25, what's in there? 5. Notice, guys, this is essential for what we're doing today, so make sure if you have any questions, please make sure you're asking those questions. So, I have nothing. So if I pull the x out of there, yes, he's gone, and as you just said, if there are 2 y's and I pull out one of them, there is 1 remaining. Okay, last but not least, if I pull a 5 out of 10, what's left over? 2, not a 5, right? A lot of people keep telling me 5. So there's 2 left over. If I pull out one of the x's from x squared, how many is that? 1x. Any questions on that one? So as I continue on, here's the last number, and number 5 is very important for today's lesson. We will keep this in today's lesson. Not necessarily this problem, but, and one of our steps today, this is one of our steps. So notice, ladies and gentlemen, right now, what do they have in common? I can actually do 2 answers to this, so I'm going to say this one first. Anybody? They have the 2x minus 1, so if I pull that out, what's left over? There you go. Alright. Sometimes we all read things a little differently. And that is technically the answer I'm looking for. But is that technically pulling out the GCF? What is 2? And I could also pull a 2 out of this guy, can't I? So therefore I could have a 2, so this would be 2x minus 1. If I pull a 2 out of him, that would be 2x plus 1. So this could be an answer if they have that in there. More or less, guys, though, this is what I was looking for. go. So, going to our homework, what number are we looking at?
12.
18. Okay, can you read it to me, please, Addie?
Y equals 2x squared minus 4x
Minus 2?
Yeah.
Okay, so Addie, it asks us to graph this. This is a good review because this is also a big part of our year this year was quadratic, okay? Remember, part of this was finding our vertex. We always have to find our vertex. Addie, you remember how to find your vertex? What formula? Very close. Negative b over 2a tells us the x value of our vertex. So in our case, we have negative 4 over 2 times 2. So therefore, 4 over 4. So our x value of our vertex, which we call the axis of symmetry, it is 1. Now, Addie, if I have 1, how do I find my y value? Plug 1 in for x, exactly. So, y equals 2, 1 squared minus 4 times 1 plus 2. So 1 squared, 1 times 2 is 2, minus 4 plus 2 is 0. You okay with me there? Now, I believe that the whole thing was to ask us to graph this, correct?
It's minus 2.
Oh, minus 2? Okay, so that changes it up. I apologize. So that's a minus 2. Okay, so that's minus 4 minus 2. I apologize now. Thanks for my correction there. 2 minus 4 is negative 2. Negative 2 minus 2 is negative 4. Better. You okay now? We all good? You good. That's important, right? Let's do that first. 1, 2, 3, 4. Now, this is our vertex. So what does that tell me, Addie? Is this the high or the low? The low, because my a value is positive 2. So therefore, it should look like this is the low point. Okay? Now, remember the next point that I like to pick is my y-intercept. If you recall, the y-intercept is the c value of standard equation, which is what? Negative 2. So I'm going to do this in pink. Here's my vertex. Here's that. Notice how many units was it to the y-intercept away from my vertex? 1 unit. So that's 1 unit to the left. If I go 1 unit to the right, it should be the exact same. Notice this is a quadratic, so it should be more U-shaped or V-shaped. Good. Okay. Today should be the day that you're not tired because it's falling back anymore. There's no awesome. How about you? We only fall back an hour, dude. Okay. Anybody else have one? This was once again number 18, you said, right? All right. Anybody else got one extra homework question?
12.
12?
12.
12 says 4x to the 6. So 4x to the 6 plus 32 cubed with this one as well. Okay. I'll just put that. X to the 4, y. All right. So, whose question was this again? Amendolia? Amendolia, what does 4, 32, and 16 all have in common number-wise? They all have a 4, right? Is everybody comfortable with knowing that they all have a 4? Can you understand how your times tables can come in here really easily? If you know them, it makes it 10 times quicker. If not, you're using machine to help us find these, right? Does that make sense? So, pick up your times tables if you guys can. So we're pulling out a 4. Are we pulling out anything else? Any x's? How many x's do we have here? X to the 6, or 6. Who has the least amount? X cubed. So that means they all at least have x cubed, don't they? Do they have any y's in common? No, because this guy does not have a y. The x is 4x to the 6, right? So, I pulled out the 4. I pulled out 3 of his x's, so how many is left over? X cubed, right? Make sense to you? Okay. I pulled out 4 from 32. What's left over on the number? 32. So 4 times what gives me 32? 8. You were at 8. What did you get? I pulled out x cubed. Is there any x's left over? How about y? Y squared is still there. I pulled out 4 from negative 16. What number's left over? Negative 4. I pulled out x cubed. Is there any x's left over? 1x. Correct. Is there any y's left over? Y. Any questions? Hanneman, let's go. If you guys need to, if it is not completely done, I do not want them. Make sure you are good to go and understand exactly every problem. Then don't turn it in yet, huh? Here we go. So today, ladies and gentlemen, we are factoring trinomials. So what I mean by that is we're going to get there, okay? So let's start with something we know. Okay? Let's say I have 2x plus 1 and 3x minus 2. What would we do if this was the case? What would I probably ask you to do? Distribute, right? Everybody understand the distributive process? Can you guys take the time right now to distribute, please? Okay? Okay, here we go. So, when we went ahead and multiplied through, can anybody let me know what their first process is when you multiply through? Andrew, do you mind helping me? Okay, some people have heard of the acronym FOIL. That's correct. What does the F stand for in FOIL? First number. So tell me what you get when you multiply the first numbers together. Okay, because we got 2x times 3x, which is 6x squared. Now, this is his personal way. Is this anybody else heard of FOIL? Maybe. If you don't, it's just basically once he's taking the 2x, that's fine to 2x, right? Next part. What does the O stand for, do you think? That's okay. Alright, keep going. So then therefore, we're going to take the outside, so I'm going to take the 2x to the negative 2. What do we get there? Okay. The I stands for inside just because he wrote this. Now, really, do we need actually this acronym to know this distributable through? No, you really don't. I mean, it's just multiply the first term to both terms and then the second term to both terms. Right? Okay, so now we've already done the first term to both guys. So now we're taking what? 1 to 3x. What do you get for it? 3x, right? And what do you get when you do 1 times negative 2? This is called the last. Okay? Is that it? Is that all? Yes. No, we could combine like numbers, and what do you get there, Vanessa? Negative x. Good. Ladies and gentlemen, today our goal is to move this back here. Take a trinomial. It's not hard. If you guys follow the steps I showed you today, it's fairly simple. It looks hard, doesn't mean it's not. Okay, is it long and tedious? Maybe. Okay, but also recall, remember, last time I showed you how to distribute after Mr. Huff showed me a new way. I've never thought about it. Remember, by taking this and distributing to him, what did it look like? Remember, it looks like 3x and 2x plus 1, right? And then we take the 2x plus 1 and distribute to the negative 2. And I could still get, notice, 6x squared plus 3x here minus 4x minus 2. I still have the same thing, right? It just looks different. But this kind of looks like our belt wedge, right? And we're going to use that today a little bit, okay? is show you how to factor. If you guys saw on the last problem, notice how did the first number come about? Multiplying to get a 6, correct? Where did the last number here come from? Multiplying the last two numbers. And if you'll notice, the inner term came from adding two factors together that were actually multiples of 12. Okay? So going on to our problem, my first step that I always do is I do what I call my rainbow. Okay? So I take 6 times 2. What is 6 times negative 2? Negative 12. And I do this right over here. So put negative 12. Okay? Write that down. I take my first number and I multiply it to my last number. So basically, guys, once again, I'm in standard form there. Ax squared plus bx plus c. Where in this case, my b and c values are negative. But still, I'm in ax squared plus bx plus c. Correct? Does everybody see that? Notice I just multiplied my a times my c. Okay? A times my c got me to be my negative 12. Everybody there with me? Okay. What I do now is I do my factor chart. What are the factors of 12? I don't care about negative 12, I care about 12. 1 and 12. Good, remember we ask every number, don't we? We don't skip numbers because when you skip that number, it's the time you want to use them. 2 and 6. 3 and 4, and since it wraps around, it shows that we are completed. Okay? Remember, as I just said over on this page, my middle terms came from things that multiply. This is 4 times 3 multiply to be negative 12, but guess what they add to be? Negative 1. So our goal here now, ladies and gentlemen, is looking at the factors. These are the factors that times to be 12, but which one get me to be 1? Well, what I do is, because this is negative, I go ahead and subtract. Because notice, how do we get a negative number? One has to be positive, one has to be negative. So when I add those together, isn't that the same thing as subtraction? Where one's positive and one's negative. Right? So I go ahead and I subtract. 12 minus 1 is 11. 6 minus 2 is 4 minus 3 is 1. Ladies and gentlemen, that tells me I am going to use these guys right here. The reason being is they add to be what? Negative 1. Okay? So watch what I do now. So I keep my first term, 6x squared. Now what I'm going to do here is I'm going to change, how do I want to say this? I want to change the way it looks, but not the value of the expression. Okay, and as soon as I write it, I think you'll understand what I mean. So, how do I get to negative x? Is that negative 4 plus 3, or is that 3, or is that 4 minus 3? Negative 4 plus 3. Ladies and gentlemen, did I change the value of the expression? Did I change the way it looks? Yes. Yes, I did. Notice this is not the same as this, right? But did I change the value? Ryan, 6x squared, right? Can you tell me what negative 4x plus 3x is? Negative x, right? So therefore, negative x is still this. I didn't change the value. It's still here. It just looks different, correct? And then the minus 2. Yes, ma'am. From this number right here to here. Okay. So what you're looking for is, you're looking for numbers that times to get negative 12. So these are all the numbers that times to get to negative 12. Yeah. Okay, but they have to add to get that negative 1 in the middle. Okay, if you notice on your factoring, when you start distributing, not factoring, distributing, those numbers in the middle will always times be your a times your c. So in our case, notice 4 and 3, what's that times? Negative 12, right? But they add to be what? Negative 1. So basically, just to let you know, I was at this stage, right? And now I'm at this stage. So then, after this, I'm going to have something like this, and guess what? Like this expression, I'm going to be able to blah, blah, blah. It might not be exactly like that, but it's pretty close. And then, I'll get up to that. It's just a piece by piece working it back. If you see me on the next one, maybe it might help you a little bit. that means is I group the front two and I group the back two. And we pull out the greatest common factor of each thing. So, Abby in the back. What does 6 and 4 have in common? They do have X, okay, that's awesome. They do have X. How about 6 and 4, the numbers? Do they have something in common? They're both even, so that tells us at least what we're doing. 2. And if you need to, come over here. 6. 1, 6, 2, 3, right? 4. 1, 4, 2, 2. What's the largest number they have in common? 2. If you need to do that, that's what you need to do. You got to figure out what's the largest number they have in common, okay? Is everybody there with me? So I pull out not only an X, but as a 2X. Does that make sense, Adam? So, 2 times what number gets me to 6? 3. And if I pulled out one of the X from X squared, how many is left over? 1X is left over. Guys, if you are not understanding, it is very important that you ask a question. This is essential for however far you're going to go in math. If you think you're just going to end at college, not college, but high school, hopefully not, then you're going to use this the rest of the time. If you are going to go to college, I guarantee you're going to use this again. If you were a math major like myself, I used this till the last day I took a math class. It's a continuous thing that you're always going to use this back to. Okay? So please make sure you understand that I'm trying to show you a method that works every time. Is there different types of methods? Yes, there are. I was not taught this method. I was taught a guess and check method, which sucks to high heaven. Okay? Not a good method. Yes, ma'am. This part? Because once again, if you look back at the previous example, notice from this to here, that was a step, right? So for me, remember, I'm here and I'm trying to get back to there, so I'm kind of working in reverse. Does that make sense? And so what I'm doing is looking for things that multiply to be -12, but add to be -1. And those are the two numbers, 4 and -3, -4 and 3 are the values of times to be 12, -4 times 3 is -12, but add to be -1. And I rewrote it so that I can go from this step to this step to this step. Did that answer your question? All right. That's pretty good. So, I pulled out the 2X and I'm left with 3X from this guy. If I pull a 2X out of here, again, what would you get? What kind of a 2? -2. Okay, does everybody see that? Yes, no, maybe so. Okay, now, ladies and gentlemen, what does 3X and 2 have in common? They only have a 1, don't they? Because what's in 3? 1 and 3. What's in 2? 1 and 2, right? Do they have any number higher than 1? No, so I pull out a positive 1. Everybody good there? So if I pull a 1 from 3, am I really doing anything? Still 3X minus 2. At this stage, this binomial, gosh darn, better be the same. If they're not the same, you did something wrong. Okay? So that's like a checkpoint. Make sure that those are the same thing. Okay? Now doesn't that look like number 5 is a Velcro? Yes, I already showed you guys that last step, so you can see that we're pulling that out. Notice, they are currently sharing this 3X minus 2, so that's what's going to be pulled out right now. We're pulling out the 3X minus 2. So with that being said, if I pull out the 3X minus 2, what's left over? 2X plus 1. And if you look on the previous example, what we went ahead and distributed, those are still the same binomials. They might have been switched, right? But is multiplication okay to have 3 times 4 and 4 times 3? We can switch it without changing values, right? Makes sense to you guys what I'm saying? 4 times 3 is the same thing as 3 times 4, right? If I went ahead and did that, then it would be okay. And that's our goal. Okay, looks a little different, right? A little process that we got to go through. So, the best way to do this is through practice. Let's do some more. You guys ready? we don't want to go back to it because that's where we started. We want to go back here. You guys remember factored form in quadratics? Right? y equals a parentheses x minus b parentheses x minus q is in factored form. We're going to start to solve factored form in here. So hopefully on this time it's a better round because now you've seen it already. Onward. This is something, once again, guys, that you cannot forget. Please don't learn and forget this one. This is one that you have to know throughout the remaining time of math, okay? And the more you do, the better you'll be. I'm telling you right now. My pre-calc kids, that's the thing that is still struggling. If they don't know how to factor, that's what they're struggling with. Not the pre-calc idea, but the factoring. Okay? It's a concept you need to master. Okay? Onward. Here we go. We are going to factor this. To answer your question though, Jackie, can I multiply it through to make sure that it was what it should be? You know what I mean? Distribute back and say, did I get the right two things to get back to where I was supposed to be at? Sure. But my final two answers is at the final. Okay? All right. You ready? What's my first thing I do? Take my front number. What's my front number? Even though he's not here, this is a 1, right? Everybody with me on that? You with me on that? You gotta tell me, let me know. Then what do we do? You understand that's the 1? 1 times 30 gets you what? It is 30x squared, but all I'm caring about is the coefficient thing. That is true, it should be 30x squared, but I'm caring about the coefficient. You could write 30. You could write 30x squared. I'll do a little chart over here because you asked. You said it. I'm going to do it. She said that technically if I times this guy, 1 and 5 times 30, then technically I am just doing it off the line, but it is. But I'm going on from what she asked, so I can still help her. Okay. Okay. You guys ready? What do we do? 1 times 30. In this case, you're going to do over here, just let me know the method. This would be like x times 30x. X times 30x should be 30x squared, right? 2 times 15, so 2x and 15. 3 and 10. No 4 can go. 5, 6 go. And as you just said, the wraparound shows me I'm done with all my factors. So last time, remember, we had a negative 12, correct? And what did we do to our numbers? We subtracted them, right? With this being a positive 30, what do you guys think I'm going to do? I'm going to add these. Okay? So, you just take the first number to the last number, your A times your C value. Now, she just said the 30x squared, so I'm going off of what she still said, so you can still use it. So, I was connecting with what she said, so maybe that creates trouble, or it won't, it still won't. So, we're going to add. Now notice, guys, how do we get to a positive 30? I can either go 5 times 6 or negative 5 times negative 6, right? Both of them get me to 30, don't they? Do you guys know whether I'm going to be both positive or both negative? Tell me what? No. A negative 5 and a negative 6 can be to a plus 30. You can't. So this positive 30 doing positive 5 plus 6 does not get me to negative 11. Screwed up. A negative 5 underneath. First off, we need to add these, there. Does everybody see why 5 and 6? Alright, so this is the pair that I'm going to use. Now, as Mike just said, he wanted to use pluses, but if I use plus 5x and plus 6x, that does not get me to be a negative, does it? Do we want to change the value of the expression? We just want to rewrite it into an appropriate thing as well. Do something that is similar. Does everybody see what I'm saying by that? So, I have x squared. Does it matter if I do the 6 or the 5 first? It won't. Doesn't matter what you want to do. Okay? Really doesn't matter. Now, me personally, I always like to do the negatives first, but they're both negative, so in this case it doesn't matter. So if I have one positive and one negative, me personally, I always put the negative first. Okay, one more time. Give me 1 second. Let me write this down. Okay, so the reason how I know they're both negative is first because of this. That's 30. Remember, I'm looking for two numbers that multiply to get me 30, but add to be negative 11. So for me to add to be a negative 11, they both have to be negative, don't they? Well, isn't, okay, so this is saying negative 6 plus a negative 5. Same thing, right? Right? You okay with that? Just be careful. I understand you're trying to tweak my words, but does that make sense what I'm saying? Do you understand that it's the same thing? Okay, so if I had 3 minus 5, what's that in? What kind of a 2? Okay. What if I had 3 plus a negative 5? What's that in? 3. You just did it right there. Isn't a plus times a negative still? Isn't this the same thing as 3 minus 5? When I was in pre-algebra, when I taught pre-algebra, I don't know if you guys were, they never let you subtract when I taught it. They always wanted you to add the opposite. And you guys remember that term, adding the opposite. So that's subtracting, well, that's the same thing as adding the opposite number. And if I had $3 and I subtracted or added a negative 5 amount, everybody there with me? Okay. I'm going to erase that though. Are you okay, Mike? Alright. So technically I am still adding to get to be negative 11. Alright. So, once again, our third step is group and group. Brian, you might help me on the first group? What do they have in common? X squared and negative 6. Do they have any numbers in common? They have a 1, right? Do I really have to write a 1 when you're pulling that out? It's okay to. They have, what did you do? What did you say though? They have a X in common. And I could put a 1X there if I really wanted. Okay? Nothing harm pulling that. So I pull that out and I'm left with, if I pull out one of the X's from there, what do I get? X minus 6. Okay? Now, and go. What does negative 5x and 30 have in common? Why would I want to pull out, okay, this is a great comment. She just said negative 5. Why would I want to pull out a negative 5 instead of just a 5?
So, if you never want your x to be negative, and when you add 5, then the parentheses have to be negative.
Exactly. Well, because once again, like I said, on the previous example, right here, these, the guys in blue right here, they have to be the same, right? Okay, so notice that's a 3x and a 3x. So notice, on this example, I've already pulled out what the binomial should be. It's x minus 6. So if I pulled out only a 5, that would have been a negative x. Is x and negative x the same? So I know I did it wrong. So as she said, to be honest, anytime your first term or your third term are negative, pull out a negative number with it. Okay? So me personally, I'm going to pull out a negative 5. That's not the greatest common factor. And if I pull out a negative 1, Mike, that is not giving me the same binomial. No, you cannot pull out negative 1. It's still 10. Okay? You're always pulling out the greatest common factor. Okay, so if I pull out negative 5 here again, notice the negative 5 is left over, so that's an x. If I pull a negative 5 from a positive 30, what's left over there, Brian? There's Brian, right? Negative 5 from a positive 30, what would be left? When I pull it out, it's like dividing it, right? Negative 6. Because 30 divided by negative 5 is negative 6. I appreciate you going with me. I just think you were not paying attention. That's why I kind of called on you. I like it. Okay. But, once again, are these the same? If I pulled out a negative 1, or if I pulled out a 5, would have they been the same? No. So therefore you couldn't continue on the next step, because I cannot factor out the x minus 6 unless they're both x minus 6. Right? Does that make sense to you? Okay? So notice, pull out the x minus 6, and I'm left with x minus 5. Now, asking Jackie's question, could I go ahead and check my work by distributing through? That is my answer, but could I check it? Sure. Okay? Should we try another one? One more before you go? Here we go. You guys ready? Sure. Thank you. Okay, this one's slightly different. 9x squared minus 25. Ooh, slightly different. Will you go fly a kite up where the mountainside passes up? Okay, what's different on this term than the other guys? What are we missing? Go ahead, Tyler. The b value, huh? Actually, I'm not missing it, because isn't this the same thing as this? Well, it's 0 times x. It's 0, and then does that change my value when I write it that way? How are you, Abby? You ready to help me on this one? What's my first step? The rainbow thing. So that's 9 times negative 25. Don't put your stuff away, guys. We're not ready to go yet. So that's negative what? 225. If you had 9 quarters, that's $2.25, right? Yeah. Okay. So, we got to go through our factors. You guys ready? Can anybody think about what you should always check first when there's a 0 in there? How do you get a 0? Go ahead. That is the same. So therefore, what are numbers that times the same number together to get that number? What do they call it? Perfect square. So can I take the square root of 225? Everybody with a calculator, if you don't know it, I personally know it. So what's the square root of 225? 15. 15 times 15 gives me 225. But because he's negative, and Tyler already said this, I have a negative 15 and a positive 15. That gives me a 0, right? That's what you were saying, right, Tyler? Okay, so what's our next step? Rewrite, correct? I'm going to go just a little bit quicker to make sure you guys get out of here. Me personally, I like to put the negative first. Does it matter? No. Hey, Hunter, what's the next step I do, brother? My brother? You're my brother.
No, I'm not.
Thank you.
Okay, you can't say I'm a dog.
Anyway, are you a dog?
Yes.
Come on, Tyler.
I'm kidding. See my mom.
Not that it matters. Anyway, onward. Hunter, do you know what the first guy's having and 15. What's in 9? Do a little tree and finish the tree. 1, 9, and... Can 2 go?
Yes.
No. Can 3 go?
Yes.
Stop, Jesse. It's really not paying attention. 3 times 3, right? Okay, what about 15? What's in 15? 1, 15, 3, and 5. What's the largest number they share? 3. Does everybody see the 3? So I factored out the 3x, I'm left with 3x minus 5. You guys, I'm hustling just a little bit. Okay? What do these guys have in common? 15x and negative 25. Kylie? 15x and 25. No. 5. Because notice, I don't want to pull a negative unless the third term's negative, okay? Unless the third term's negative, do not pull out a negative. So just a 5. And that's a plus 5 then. And notice that's 3x minus 5. So if I pull out the 3x minus 5, what's left over? What's left over? 3x plus 5. Ladies and gentlemen, you're doing this over and over and over again. If you check my website, I can give you an extra credit point on your homework if you find out what I put on the Love Late recording.